So what I'm going to go ahead and do is just create the save game once again, and save and quick save and quick load, quick save, 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 quick load. And we're going to watch the timer events just go wacky for a bit there, because that's not what it's supposed to do, obviously. It's actually supposed to stop at 50, and as you saw, the last number that actually ran was 57. The goal is to have a useful, maybe not competent, but useful tutorial on the timer events in Fallout 2. First of all, Tiger Newt was kind enough to write a small tutorial on timed event pproc in Fallout 2. He gave us a brief explanation about what's going on here. So I'm going to first create a new map, second, set up that new map, and then third, introduce the timer event, show how it works, and then show a couple of problems with it if you don't configure it correctly. So the first thing we're going to do is going to go ahead and open the mapper. So we have these characters set up, so I'm going to go ahead and Alt-F save as, and we're going to create a new file, timer map save. There we go. So I have my new timer map. I got to close it because now I have to write the script part of it. So the script part here, it's going to open the Sfall Script Editor. We'll make a new critter script like we did last week. And we don't need the debug info yet, so we can just shrink that down. Now, we don't need any of this information right here. These are all settings for if you actually wanted to do something with the critter. We're not going to do anything like that. There's a whole bunch of these that we don't actually need here. In particular, we don't need talk pproc, use scale on pproc, damage pproc, or destroy pproc. But we're going to leave them in here because the script itself likes to have them in here, and sometimes that's a good idea to do or not. Like if I have to get rid of those two. So anyway, all we need here are start, map inner, and critter pproc. And even then, we could probably add one more, which should be map exit pproc right there. And we're going to give this a save as. We're just going to call this one timer, like the map. Although this is not going to be a map script, so I'm going to add something in here so that it doesn't accidentally call it the map script. A timer, like that. A timer. So we're going to need the map inner pproc. We need the critter pproc because we're going to do some testing with it, and the map exit pproc. And then one more thing that people tend to like to put at the top is a timed event pproc, and that's where we're going to have our timer events actually running. So in Fallout and Fallout 2, there is this thing called a timed event, which uses timers, and basically it's used to animate critters to walk from one spot to another, or to provide some sort of reactivity to the player. It can also be used for floats. It can be used for just about anything in the game, but it has a few limitations to it. I'm going to explore that a little bit here today. But in order to create a timed event, the first thing you need is a procedure timed event pproc. This timed event pproc, I don't even know if it's part of the engine per se, but it is definitely a called and has a time delay to it when you call it. So on the left here, I'm just going to go ahead and borrow a timed event pproc that I've written already. We're going to put a float message up here. And float messages have an object pointer at the start. So self object is the object pointer I'm going to use. The string, the message. I'm a timed event. Close that string. And then a color for the float. And then it's float color. We're going to go float color good for now. Just for fun. Close that out. Put a semicolon at the end. And that is the end of our float instruction. Really, really simple. Just going to have a float. But the thing is, when you create a script and you go to compile it, there are a couple things you have to do. You have to go to your list over here button. You have to make sure the script is registered. There's a little button right here. And you don't necessarily have to add it to the header file. It does make some things easier to add it to the header file, but you at least have to register it, because what this does is it adds it to the scripts.list file. So you can use it in the mapper. So once it's registered, then you go ahead and compile it, and then it's compiled. And in theory, as long as you have everything configured correctly, it should compile directly into your Fallout 2 directory. That will allow you to add it to your mapper. Let's open up that map I just created. And we can edit our characters. There's a little edit button down here, or you can press the E key. Either way, it does the same thing. We're going to go new script right here. And there's a timer, although you can barely see it on this screen. But anyway, there's a timer.int. That's what we're attaching to this critter. And we're doing the same thing to this critter, so we can just see them both happening at the same time. New script, because you're allowed to attach the same script to multiple critters, which is used in different ways depending on how you want to use them, but it's not really important right now. Both these critters have a timer attached to them. We go into Alt, File, Save the map. We can close this for right now. And now, as long as you have your mapper configured correctly, the map is going to be in your Fallout 2 directory under data/maps. And there's timer.txt, timer.edge, and timer.map. Timer.map is the map we've actually created. Timer.edge is something for the high-res mod. And timer.cfg is, what the hell is this? Oh, I don't know. It's something binary. I actually don't know what it is. So now we have that set up. Now the next thing we want to do is actually go ahead and go back into our Fallout 2 file and open up our ddraw.ini. And then in ddraw.ini, we want to set our starting map right here, which I have already set to something I was testing out previously. I've got a bunch of other previous tests. We just semicolon in front of it, and then we just go ahead and add another starting map entry. And we're going to give it the name of our map, which is timer.map. Then we just go ahead and start our game. Create a new character. We can take the default, it's not really important. And here is our timer map. Now, I want to point out there are two critters here. Both of them have the timer script attached to them, but nothing is happening. Even though I told it to put a float in the timer script, obviously we're not calling the timer. I've only configured the game to actually start on this map. If I went ahead and tried to create a save game on this map, it will work, but then if I try to reload that save game, it crashes. Now, the reason this crashes is something that I've covered in the map configuration video, but the solution to it is really simple. We just go into here and we go to our data/data folder and we go to MAPS.TXT and we open up MAPS.TXT here. And on the very bottom of it, add your map to this list, map 153, and it has to be in order. You can't skip a number as far as I'm aware. And you can literally just copy these lines right here and just rename them for your map, which is timer. No timer.map, it's just timer on its own. And then file, save, and then you can close your maps.txt, and then you can close your ddraw.ini. And if you go out here and start the game again, you should be able to actually load that last save game, and you're all set. And the reason I'm doing this is because we're going to save and reload on this map a couple times to show a couple of bugs that happen with a timer. So there's our timed event pproc, but of course it's not getting called yet. And the reason it's not getting called is because we're not actually calling it. It's not actually running at this point. You can also do it on a critter pproc. You can also do it in like a dialogue. You can do it anywhere. But there are two really common ways of doing it, from the critter pproc or the map editor pproc. Now the critter pproc is where I'm going to start with. All you have to do is use this command. Add timer event. Object is the first entry here. So if we hover over it, you can see that it's looking for an object pointer, object int time, which is the amount of time until it triggers, and then the int info. And info, though it's not really well explained here, is just a number that you use to indicate which timer event you want to run. Because your timer events are apportioned not by name, they're apportioned by number. But you can kind of make them apportioned by name. I'll show you that in a minute. So anyway, the definition for this is adds a timed event call to the queue at a given time offset, remember, to call an object's OBJ script. And it doesn't call an object script because that's not accurate. It actually calls whatever you put into the timed event pproc to run. So I'll show you that in a little bit. Info is used to let scripts differentiate between timed event calls. So the last entry, int info, int it means integer, info is the name of whatever this spot is. And it's used to let scripts differentiate between timed event calls so that they can be hooked in multiple times. Info is read back to the script using the fixed param operator, and I will show you that in a second. Note that time is in ticks. Ticks as in there's about 10 ticks per second in the game engine on normal speed. And that means that you can have a timer event running 10 times a second in theory. How much the delay is before it's called is in ticks. You can use game ticks and then the seconds number. So the number of seconds you want it to return is returned using the game ticks function. I'll go over that in a minute. To get the time and ticks from the time and seconds. Okay, so the add timer event, object pointer object. So the first one we want to do is self object. It's like the most common thing in the world. Self object points to whatever critter is running this script. So I have two critters running this script. It's not going to differentiate between the critters. Both of them will run it at the same time, and it will point to the critter the script is attached to. And then the second part is the delay before the timer event actually starts. So I'm going to put first just the number 10. And then we'll do game ticks in a second. And the third part is the actual timer event number. I'm going to put 0 because 0 negative numbers, you can do any integer, any actual integer, but really you're not going to have that many timer events, and you should really just use like 0 through 10 or something like that. We're going to go in a little more detail on that one, but right now, here's the timed event pproc. Now we have this command. Now the thing is, this actually isn't or shouldn't run this, but well, let's take a look real quick. Let's take a look and see if it does. Open up the game. So we've compiled it. We've already got the script attached to these characters. And yeah, okay, it looks like it actually does run. Add timer event call actually just calls the timed event pproc and just runs whatever. But in order to differentiate between tool timers, because it runs everything that's in here, for instance, and let me like go ahead and just do like here's oo, and here's ah, and let's go give this another compile. And as you can see, they're just flipping between ooh, ah, and the timed event pproc. No, I'm not entirely sure how much of that is actually showing up on stream because my stream only goes at 30 frames a second. What it's doing is it's just switching back and forth between those two things I wrote in there. It's not actually pausing on any of them, and it's not actually running one at a time. It's running them all in sequence at the same time. So that's obviously not really what you want to do with your timed event pproc. So the way you separate this out between these three and between which timer event you want to call, you do an if check. And in here, you check to see if the fixed param is equivalent to, which is what the double equals signs means, if it's equivalent to 0. Then begin, and then in here, we're going to throw the code that I want it to run right in between our begin and ends. So what this does is add timer event. It sets this variable, this fixed param variable, to this number. So right here, I'm checking to see if it matches this number right here, 0 and 0. And if it does match that number, then we do this. And then I'm gonna go ahead and say else here, begin, and end here. We're just gonna put these two in between the else statement so that they don't run, because this is the only one that's gonna be called. So let's give this a compile. Start that new game, take that character, and now you can see only one line is coming out, and that is the line that I specifically created here. I'm a timed event, and that's the only line that's being showed up. That's the basics for how to actually get a timed event working in the game. That's the very, very basics to it. Now, because this is the only thing that will ever be called is fixed param 0, comment this one out and call this one fixed param 1, and it will run the other two, but not this one, which is kind of silly. You don't really want to do it this way. It's disorganized and other people can't really read it very well, but it'll do it. So those other two are being called, but not the I'm a timed event line. So ooh and ah are both being called, but not the third one. That's one way to do it, but it's a bad way to do it. It's not really considered very kosher. So don't really do it this way if you can help it. But all you have to do is exactly the same thing as you did in the first one. And now you have two timer events here. One's fixed param 0, one's fixed param 1. And you can have them running in separate areas if you want. There is no fixed param 2 right now, so I'm not going to worry about that. I'm going to run that as a test, and it's going to do the same thing it did before, so it's not really all that special. Timed event 0 is running. It's flickering in the background, though. You can kind of see it as it stins out there every once in a while. Okay, but we don't want them all to run at the same time, obviously. Necessarily. Like, there are situations where you want multiple timed events to be running at the same time. Floats and animations going together and stuff like that. But if you don't want them to run all at the same time, you generally don't want to be calling them all from the critter pproc. That's a really good point. What's up? Before we get any farther here, we can actually delay the timed event with this number right here. Now, this is 10 ticks. 10 ticks means 1 second. If I gave it 100 ticks, 100 ticks is 10 seconds in theory. Now, you don't have to necessarily convert it yourself, but as you can see, now we're waiting 10 seconds for the actual fixed param, the first one, to fire off. Now, because the critter pproc runs 10 times a second, it runs once every tick, you're still going to get 10 fixed params called every second, but it's going to take 10 seconds for that first one to call, which is why you don't necessarily want to put these calls in the critter pproc. When putting this in, you don't actually have to put in like the number of ticks. People are familiar with seconds and not very familiar with ticks. So what you can do is call game ticks on it, and you pass in the number of seconds you want. whatever you call game ticks on will return whatever number of ticks there are for that number of seconds. So game ticks of 10, display, I think it's display message, right? Yeah, display. This will show on the little taskbar what game ticks 10 returns, which is going to be 10 seconds here, which is going to be the same thing as 100 ticks here. Give that a compile. And as you can see, game ticks of 10 seconds returns 100, since 100 ticks. So 100 ticks is going to show up over here. That's how long it takes, 10 seconds for it to go over here. Does game speed affect game ticks? Yes and no. Game speed speeds up the entire game. So if you have 10 ticks a second on normal game speed and you're playing at 10 times game speed, it's going to be 100 ticks a second as opposed to 10 ticks a second, but the entire game is sped up, so it's all going to match, and you won't really be able to tell the difference. There is, as far as I know, no easy way to tell the game speed, so you can't really design this around the game speed yet, which would be really nice if you could, for the floats in particular, but that may come in the future, and if it does, I will try and make a video that covers that. Because people are still working on the Sfall mod, so it's entirely possible it'll come in the future. Anyway, okay, let's get rid of this line. We don't need it anymore. We already saw that the game ticks 10 comes out as 100 ticks, rather, which is 10 seconds. And these two are equivalent. Now, there's a couple of ways of making sure that these don't overlap each other, so that it only plays one at a time instead of playing them both over and over and over right next to each other. One, you can have, like I said, we have this global variable up here, fixed param check. You can just do a check here. If fixed param check equivalent to 0 or true or false, you can do all of these. They all work the same way. Then begin. I'm going to go with true here and end here. And let's go ahead and type this over 1. So this will only run if fixed param check comes back true. We're going to initialize it to false just to make sure it starts out false. And then we can have a second check over here where it says else. Usually this is actually lined up after the end, so else. We don't need an if, because if it's true, then this will run, and then if we do else here, if it's false, this will run, and then we'll go ahead and put an end down here to just complete out the statement so it doesn't have this red squiggly line. And the number of ends has to match the number of begins, just to be clear. That's what, if you ever see that red squiggly line, you see this thing say expecting a semicolon, expect a semicolon or something that would end this previous statement. There's an extra end that was missing here. I took it out, and that's one of the more common bugs you'll run into. Now for this check, it's going to start out as false. These two will run on their own, but this one won't run, even though they're both being called at the same time. We compile this, run it, wait 10 seconds. I'm going to actually drop it down to 2 seconds instead of 10. And as you can see, the third one isn't being called. Hopefully you can make it out. There's only ooh and ah here. Now, even though they were both being called, only this one ran, and that's because this fixed param check that I have right here prevents the other one from running. Now, you can do something a little bit fancy with this, and you can actually add another timer right here to swap the fixed param check around. So you can do it this way. Fixed param check equals true right here. So it'll print this one, and then it'll print this one. Turn down the amount of time from 100 to 20 or 2 seconds, depending on how you want to write this out. There we go. So you saw, let me go ahead and start it again. You saw briefly the ooh pop up, hopefully. And then the timed event started up right after, because that's immediate. But instead of just having it immediately setting it to true, what you can also do, add timer event right here, self object. The amount of time you want it to take, we'll give it another game ticks 2 seconds, comma there, not period or semicolon. We can actually change this to, let's not do fixed param 0. Instead, let's cut this out and let's put fixed param number 2 right here. We have 0, we have 1. We're going to create a new one right out here outside of this entire if check. If fixed param equivalent to 2, then begin. And we're going to set fixed param check to true right here with semicolon 2, close it out so that that red squiggly line goes away. So now this will run. Once this one runs, it's going to wait 2 seconds and then set this one to true. So let's give that a compile. There we go. There's our ooh. Wait 2 seconds and it comes to true. Let me go ahead and start it up again. Ooh, 2 seconds. I'm a timed event. There we go. So that's that delay. That's one way of writing it. This specific way of doing it, you can actually change whether or not the fixed param is being called based on this outside global variable here. That's one way of actually telling it to call or not call based on an outside check. Another way of doing this is we can actually get rid of this. So you don't have to have this fixed param call here. You can have this fixed param check called anywhere else in the script to turn it on or off. And that's one way of handling multiple fixed params being called at the same time. But we can also get rid of it, pull it out of here. There's another way of handling this as well, where instead of calling both of these at the same time in the critter pproc, we can comment out one. We'll call fixed param 0 here, but then in fixed param 0, we're going to add another timer event, and in this one, we're going to call fixed param 1. So the first one is going to call fixed param 0. It's going to go up here, run this, and then when it calls fixed param 0, it's going to add another timer event, which calls fixed param 1. And it's going to be 2 seconds right there. So that's what it's going to do. It's going to call this, and then it's going to call this after 2 seconds. So give that a compile, run that. I'm a timed event, and then ooh. And so you can see right there, one more time. I'm a timed event, and then ooh. So there we go. So that's one way of actually handling. Now, if you wanted them to go back and forth, you could have this one basically calls this one, and then we can go ahead and say add timer event right here, self object, and then game ticks 2, and then we're going to call timed event 0, and then semicolon that. So now this is going to call number 1, and then this one's going to call, oops, I think we have too many parentheses there. Going to call number 1, and this one's going to call number 0, and this one's going to call number 1, and this one's going to call number 0. So it's going to go back and forth with a 2-second break between each one. So let's give that a compile. So here's our first one, timed event, ooh, timed event, ooh, timed event, ooh. Call itself over and over again forever. Now, I want to point something out. So I'm going to make another variable, number, I'm going to call it. We're going to initialize it to 0. By the way, you can use this colon equals or just the equals for the assignment operator. Both of them work. The equals is new. The colon equals was the original language implementation. Doesn't really matter. As long as you have the newer version of Sfall, this will work fine. So we have our number here, but in each time we call this, we're going to add one to the number. And we're also going to display the number. So in our float message, I'm a timed event, comma space number, colon space right here, and then plus our number. This is the string that we're initializing it, and then we're adding a number to that string so that it'll actually show the number in the string in the float. It's sometimes nice to wrap these in parentheses so that you can see a little bit clearer what the actual string is. It's not necessary, but it's sometimes helpful. And do the same thing here, ooh, comma space number, and then we'll put a plus number here. And we're going to do this for a reason, because at this point, we're going to say number. You can't use plus equals, unfortunately, but you can use equals number plus 1. Compile that, run it. And now, notice those numbers. Look at that number. That number is like 5,000, 6,000, 7,000. It's absurd. What's going on here? We got our timed event number, and in fact, they're like overlapping each other. What the heck? So why is the number going so high? The reason is really, really simple. The critter pproc down here, which is running 10 times a second, is actually adding another timed event pproc check every single time it runs. But the first time it runs this, it calls this. The number starts out at 0, and then it's going to add 1 to it. And then it's going to go down here. Then this one will come back here and call back to this one. But at the same time, this one calls back to this one. Fixed param 1 calls back to fixed param 0. This is also calling back to fixed param 0. And actually, not only that, this is actually doing it 10 times a second, whereas this is only doing it every 2 seconds. This one's calling 20 of these at a time for every time one of these runs. So you have to watch out for that, especially in critter pproc. This is not necessarily the best way of doing a timed event pproc at all. There's a really easy way to demonstrate this that I've recently run into in the Mutants Rising mod. Highly recommend the Mutants Rising mod. I am working on it, and I highly recommend you guys check it out here. And that is with a random walk. So I'm going to, in here, I'm just going to copy paste this code. It's not going to really do anything but demonstrate visually what I'm trying to show you. So in here, in our fixed param 0, we're going to have a reganim clear on self object, which just clears the animations. A reganim begin, which is an animation loop call, which is kind of interesting. I need to understand this a little better before I make a video about it. And then animate, move object to tile, self object, tile num a direction, tile num self object, random 0, 5, random 3 to 8. So this call right here says, we're going to move you in a random direction, a random distance from 3 to 8 hexes. And then 0 at the end here is walk, 1 is run. It's not really important. I'll just show you why. And then reganim means the end of the animation loop. Okay, give this a compile, and let me show you what happens now. Okay, does that look right to anybody? The random walks aren't supposed to look like that. This is not what a random walk is supposed to look like. But this is what happens when you do something like that, and it calls a number 10 times a second from the critter pproc in particular. You can other situations where this will happen, and I'll show you those as well. But I just wanted to point that out. First of all, it's typically not a very good idea to just go to the critter pproc, just call this up, because this will actually add multiple timer events over and over and over again. In fact, just to show that off one more time, they'll go for a second and then they'll pause, and they'll go for a second and then they'll pause. What's happening is the random walk only, and in fact the entire engine actually is slowing down. You can see the frame rate dropping, hopefully. The frame rate is totally dropped. Even though the speed of it should be going higher, the engine itself is just starting to wag out on you. It's really, I can't even get him to move, jeez. So what's happening is for 2 seconds, the timers will build up, and then for the other 2 seconds, they'll actually run, because I have them set to space out at 2 seconds apiece. Put a flag so it runs once. Well, that's what I was showing. You can make a flag so that they only run once, but a better option is to not actually put the add timer event in the critter pproc, unless you have a whole bunch of checks around the critter pproc to make sure it doesn't run every 10 times a second. Instead of putting it there, what most people will do is they'll pull it out and they'll throw it up here in the map inner pproc. Now, the map inner pproc runs once when you enter the map. But the thing is, the engine kind of handles map inner pproc in an odd way, so there are ways of causing bugs with this as well. So I'm going to show those off as well. I mean, we should see some even numbers coming in now. 2 seconds, timed event number 0, timed event number 1, timed event number 2, timed event number... Now, this is faster than 2 seconds because I'm running at a faster speed right now. But now, as you can see, it actually alternates between the two, and it gives you that 2-second clearance, and the number only increments once per 4 seconds here. So this is a much more manageable way of handling this. Now, there are some problems with this. Let me go ahead and exit the game, start up a new one, and I'm going to create a quick save here. Here's our quick save. Now I'm just going to go ahead and reload that quick save. You notice something interesting? It's not going 1 every second, it's going 2 every time it actually increments. 8, 10, 12, 14, 16. Let me go ahead and reload that again, and let me go ahead and save and reload again. And let's do it a couple more times. And now all of a sudden, that number is going up way higher than it ever should. 18, 19, 22, 25, and everybody's in that wacky random walk that we were having before. It's happening again. And look at that. Now they're going back to the same problem we had before. So the thing about the engine, and this is what you have to watch out for when you're creating a random walk or any timed event here. The thing about the engine is that it runs the map inner pproc every time you load the game. So the simple way to fix this, and Tiger Newt, thank you. That's what I have over here on the side is Tiger Newt's tutorial. The easy way to fix this is to do an if check in your map inner pproc, and you just do this like this. If not, is loading game right there. There's a specific special check just for that. Then begin and end here. And now this will only run once whenever you load and save and load the game. Give this a compile. Quick save here. And quick load, quick save, quick load, quick save, quick load, quick save, quick load. And look at that. It's not actually going any faster. It's not doing that random walk where we're zooming all over the place. It's actually going in the order that it's supposed to. So there we go. That's the simple fix of handling the save reload situation. If the timer that's running is being saved as you exit the map without saving it in a save game, it should have done this already, but we'll take a look at this with a local var, lvar, so it's persistent rather, not consistent. So it's persistent throughout the save game. There we go. So lvar number 0, 1, 2, and I'm going to pop over here, and we're going to pop back. 3, 4, and we're just going to do this a couple more times. Theoretically, if this is doing the thing I was expecting it to do, it should do what it was doing earlier where I was saving and reloading it. It should run multiple of these at a time. But it's not doing that. So apparently on leaving the map, fully leaving the map to another map entirely, it actually clears out your timed events. So you don't necessarily have to handle this way. Let's take out this is go loading game real quick and compile that, and I'm going to show you this again. So if I leave and come back a couple times, you can see it's running, but it's running at the same rate, right? So it's not like 1, 2, 3, 1, 2, 3, 1, 2, 3. It's just going 1, 2, 3 every 2 seconds, right? Now, if I give it a save game here, reload, save, reload, save, reload, save, reload, save, reload, that's when it's calling multiple timers at the same time. That's the bug that we're running into. So that's not happening. But if I leave the map and come back, those are all still, they're gone. All those, see where it was multiple events here? They're gone now. So I save, reload, save, reload, save, reload, save, reload. They're going to be back. So that she's tweaking around. She gets like 3 at a time. 102, 107, 4 at a time. 5 at a time. 112. But when I leave the map and come back, all those timed events, pprocs, are actually cleared out. Right there. So now it's just 132, 133, 134. So all those repeating timer events, they're cleared out on leaving the map. So you don't necessarily have to handle this for leaving the map, but you do have to handle this here because you want to be able to deal with when the game loads in. Now, you can, if you want to explicitly handle it on the map exit, you can do something with this, but it's not necessary, obviously, because I just demonstrated that. But you can use a function called rm timer event. Okay, rm timer event just clears all the timers in here from whatever object that you have it attached to. What you can also do is you can put this in the is loading game, so you can just do a regular is loading game check here. You rm the timer events. It'll clear out all the timer events, and you don't even have to do that right there. You can actually just take out the is loading game check, so that every time you have a map enter preproc, it'll clear the timer events and then add that timer event back again. So that's another way of dealing with that save reload situation. Let me give this a compile. Run that. So now we got this again. So I'm just going in save, quick save there, reload, save, reload, save, reload, save, reload, save, reload, save, reload. Oh, apparently I was wrong. I totally thought that would clear the timer event on map enter. Aha, how interesting. I was totally wrong about that. Removes, it says it's supposed to remove all and clear all timer events hooked to a given object's script. That's what it's supposed to do, but it clearly isn't doing that. That may be the case. If that's the case, let's put it inside the fixed param itself. So we don't need that anymore. So now this is going to run as soon as the fixed param runs. So give that a compile. Save, reload, save, reload, save, reload, save, reload, save, reload, save, reload. Oh, that seemed to do it. Okay. Okay, so you can't use rm timer event on the map enter pproc because apparently the actual timer events are restored rather after the map enter pproc runs, which is interesting. So you can just go ahead and put an rm timer event to clear all the timer events in any of the timer events that you call, so that when they're called, it'll clear all the other timer events and it'll just run this one. That's one way of managing it as well. Now, you don't just have to clear all the timer events, you can actually also just remove a specific timer event by calling rm fixed timer event specifically instead of just rm timer event. So rm fixed timer event from here, and this one takes the object pointer to the critter that you're using it on, which is going to be self object in this case, like it usually is. self object, comma, and then the fixed value. Now the fixed value is the fixed param we're looking for. So we can call remove timer event fixed param 0 right here. And this should do basically the same thing that this one was, where it's just removing all of them. This will just remove 0 because 0 is the one that's always called on map inner. So we compile this, save, reload, save, reload, save, reload, save, reload, save, reload, and we have the same effect. Now you can also do this to use this specific command to interrupt a specific timed event. Like you have a critter walking from one spot to another, you can use this to remove that timer event and then add a different one back in. But just organizing your code well enough to handle that is usually a good idea too, and you're probably better off doing an if not is loading game check right there, as opposed to simply handling it in the fixed param. This is a little easier, and it doesn't have to call it. In fact, this prevents it from calling it in certain situations anyway, so it's not doing an extra call, an extra work every time you load up the game. The less work it is, the more efficient your scripts are, the less chance that it will actually bog down the engine, which is generally speaking a good way to approach it as well. So that's RM timer event and RM fixed timer event. The next thing I want to cover is something very basic. This is very basic because all it is a simple define. I haven't really done any defines in here for good reason, because it's a little confusing sometimes, but this makes this much easier to read. This is fixed param 0 and this is fixed param 1. Now it's tough to remember what these do just from the numbers. And you'll find that if you read a bunch of scripts that people like to just use timed events for a bunch of reasons in a bunch of situations, but trying to figure out what they do, you have to go to the code and then kind of look around and hope they commented in it. And if they didn't comment it, then you'll have no clue what's going on until you read the entire script, and that takes time and it's really frustrating. So a good way to shortcut this is just to call a define here. We're going to define what our first fixed param here, which is literally just a random walk plus a float. So I'm just going to call this random walk, and then I'm going to hit tab a couple times, and then we're going to put a parentheses here, and random walk is 0. 0 indicates this right here. So what I'm going to do is I'm going to take this random walk that I defined, and I'm going to put that right there. And all this is going to do, when it compiles it, it's going to put this in place of this. And that's all it does. It's text replace. It's all it does. It's not a variable. You can't add or subtract to it. Literally all it does is it takes this text here, anything that has random walk in it, and it replaces it with this text here. And you'll see macros that are defined this way and stuff like that. And we can get into that later. But that's all that a define does. It takes this text here, and any place that uses this text is going to have this in its place. And don't put a semicolon after this or anything like that. Just this. This way we can actually see that when we call this first fixed param, it's going to be random walk. You don't even have to write a comment here saying for random walk for the critter. So you don't have to put a comment here or anything like that. You don't even have to write anything. You just define it this way. That way anybody looking at the script in the future will know, oh, this fixed param does a random walk, and you don't actually have to look at it and kind of go back and forth in the script to figure out what it does. That's what it does. We're going to define the second one as well, float timer, and this is going to be number 1 here. Fixed param number 1 right here is going to be float timer. So all it's going to do is just have a float message. You can see it right here. It's pretty easy to read. In more complicated scripts, though, you'll definitely want to have this kind of information for people who are using it. And the reason is because all the way down here where you're actually calling it, it's not always right next to it. You'll find a whole bunch of information between the timed event pproc and wherever it's called. So coming in here and calling it random walk here tells the person reading the script and trying to debug this script, oh, this is calling the random walk timed event pproc, and you can be like, oh, random walk. And in fact, you could just do this Control F, search, and it'll find the random walk defined in fixed param. Much, much easier to find what you're looking for if you actually named your fixed params with a define. Now, a good thing to do is put an FP in front of it for fixed param, so that people will know it's a fixed param when you actually define it. And maybe having a comment up here saying, these are fixed params for time event pproc, something like that, so that people can tell what's going on with it. We don't need this top one anymore. And they can also see it's an FP for fixed param. And because I changed the name of it, I have to change the entry for it down here too. Oh, and also FP random walk goes right here and right here. There we go. There we go. So now we can see this is calling the random walk once it's done with this, which is this one, and then this one's going to call float timer once it's done with the random walk. Okay, compile. Everything else is exactly the same though. And you'll watch them do exactly the same thing they were before. Just as you would expect. Now, there are situations, yeah, there are definitely situations where you want to use a local variable that's saved as opposed to a regular variable that's not to actually determine your fixed params here. And it's for a very specific situation where you want the critter to walk one place and then continue walking to another place. So let's go and open up the mapper up one more time. I'm going to try and set something like that up. Let's get rid of one of these critters. We don't need two of them in this case. Let's get rid of this chick. So let's go ahead and hit save for that. And let's pick a hex over here. Let's say 20,090. So pound define hex 1 20090. And let's pick another hex. Pound define hex 2. Okay, so we have 3 hexes, and I want them to move from one to the next, to the next, to the next, and then restart. So there are a couple of ways of writing this. We're not going to call this random walking. We're going to call this FP walk 1, FP walk 2, and pound define FP walk 3. And this is going to be timer event 2. So walk 1, and we're going to let me just do walk 2, and then we're going to have walk 3 over here. And we're going to add one more check for if fixed param equivalent to walk 3. Then begin, and we'll do something here in a minute. Let's get rid of, we need these two, regenem, clear, regenem, begin. We're going to move to tile, self object. We're going to tell them which tile explicitly right here by saying hex 2. We're going to get rid of the float message. We're going to go and copy this like that. In this fixed param, we're going to have one float message, one animate move to tile, and one add timer event. In this fixed param, we're going to have no float message, one move to tile, and then this timer event. And in this timer event, we're just going to go ahead and have a move to tile and then a call back, FP walk 1, just so we can have it circular, running around in a circle. So this is one way of handling that. Walk 1 calls walk 2, walk 2 calls walk 3, and then walk 3 calls walk 1. So obviously we'll end up in a circle here. Each one has 2 seconds. One last thing I'm going to do is I'm going to go back to the mapper. I'm actually going to put something on those hexes so we can see what's what. Okay, so I've marked out on the map here the little triangle I'm going to have this guy walk in. Marked out with these little missile things here. So he'll walk to this one first, this one next, and then that one third, and then it should restart. So let's give this a save. Pop back over here. Make sure this is compiled. Oops, I have a bug somewhere. I forgot to redefine this to be FP walk 1 and rename it down here. So FP walk 1. This should be hex 1, this should be hex 2, and this should be hex 3. So we can actually see which one's running at which time. That's 1. That's 2. That's 3. Oh, I have this in the wrong spot. Okay. This needs to be in the timed event preproc. Doi. That's inside. That's inside. Okay, there we go. Okay. So there's number 1, there's number 2, there's number 3. So the thing you got to watch out for is you can see he doesn't actually get all the way to the spot where he's supposed to go to, where these little missiles are. Instead, it interrupts him before he gets there. You have to do it a couple different ways. Either you have to time it out and allow for the animation to actually stop, to actually end, so that he actually gets to his position. That's one way of handling it. So I can go over here and instead of saying game ticks 2, we say game ticks, let's say 4 on each of these. Hopefully that'll give us enough time, 4 seconds instead of 2 seconds, for him to actually walk all the way over to the place. So let's see. Yep, that gave him enough time for that one. Not quite enough time for that one, though. Not quite enough time for that one. but enough time for that one, just barely. Let's give it 6 seconds. 6, and another number 6, compile. And now he goes from 1 to 2. There's a bit of a delay there. 2 to 3. No delay there because that was just enough time. And then a little bit of a delay, but not as much as over here. So this one has the longest delay. Now, that's what you'll end up with. You'll end up with spots where you have a delay and spots where you don't, depending on how amount of time it takes them to get there. Another way of dealing with this is instead of walking, we can actually set the move to tile with the speed of 1 instead of 0. There's a define for the actual speed, but it's not really important. 0 is walk, 1 is run. For the most part, that's all you really need to worry about. Anyway, so you can also make him just run there. He'll get there with plenty of time to spare. But there's a better way of actually handling this that's a little more accurate, and he doesn't have these weird delays here. Let's go and swap the runs back to 0s so that he's walking instead. There we go. So animate walk is 0 and animate run is 1. So you can do that instead. Having the defines in here is a little cleaner, of course, just like it is for having these defines here to define which walk you're doing. But nonetheless, so just bear that in mind that there are totally defines for these. Animate walk happens to be the one, and then animate run is the other one. But they're just 0 and 1. So you can use the 0 and 1 if you really want to, but it's better to use the define if you can. So now I'm going to go and compile this again. We're going to go back and show you that we are back to walking around. And he's going to just walk, and there's going to be a weird delay here, and he's going to walk up here. There's going to be no delay because it's just enough time. And then it's going to get down here. There's going to be a short delay, and then it's going back over here and a long delay. So in order to avoid those delays, instead of having a timer, game ticks timer here like this, you can actually have a check here. So that if fixed param fp walk here, then you also have another check if actually and I'm busy self object right here. And then in here you have all this stuff running end right there. You don't want to check if he's busy, you want to check if he's not busy. So if not anim busy self object, i.e. he's not actually animating, then run this. So you have this check here to make sure he's not animating. We can go over here and add this for each of these. Add an end for each of these as well. For this. There we go. So that should clean it up. There it goes. Compile. This might not work because of the way it's set up here. So it might actually stop here. No, it doesn't. And in fact, that delay. Okay, the delay is too long. So let's put our delay down to 2 seconds again. Compile. So the delay, now the delay is too short so that when it triggers, it actually says, oh, we're currently busy. It's not going to run any of this, so nothing. And then it just doesn't run anything, and it actually doesn't run this here. A way to work around that is to actually have a trigger in some place where it will consistently be triggering. You can trigger the same event in the else case. Well, there is a problem with triggering the same event in the else case, but that's a fair point. We'll try that one first. Okay, so one way is to trigger the same event. So here's the if not, here's the end for that. And we do else, begin. We need another end, actually, where we trigger this timed event again. There we go. So the way this works is really simple. If he's currently animating, add another trigger for this. If he's not animating, go ahead and run the rest of this and then do that. So we can do that for each of them. So we're just going to add an end else begin here. Let's swap this out for that. And the same thing down here. It's going to be FB walk 3. Compile, run. This works. This works reasonably well. The downside to it is that you can actually have it trigger multiple times in the middle of here. Go compile. So depending on how you have it set up here, some things can happen in the middle that sometimes are not what you want to have happen. As you can see, it's actually triggering twice here, but it is continuing to walk. So in this situation where you have a walk command, this works pretty well because it doesn't animate anything weird. This works reasonably well. Okay, so this is one way of handling it. Another way of handling it is to do the same thing, but in, for instance, the critter pproc, or another good place is the map update pproc, so that instead of doing this and adding the timer here, comment that out, we actually set this call in, for instance, the map update pproc, which runs a little less often than the critter pproc, I think once a second, or in the critter pproc right here. This also prevents it from doing that weird run around thing in circles that we were seeing earlier. So the only problem with this is when you're calling the first one, it only ever calls the first one, and the first one will eventually call the second one right there. You get an even weirder delay, but then the thing will call back to the first one again, and you'll move back to the first one instead of going to the third one. So as you can see, that's what happens. And then, so you only get 2 of those running. The solution to that, if you want to do it this way, the other way is better, but if you want to do it this way, is to have a variable that changes. So like variable walk number is equal to walk number plus 1. And then if walk number is equivalent to 3, I'm sorry, 2 is the highest, then walk number is set equal to 0. Oh, we need to initialize walk number to 0, actually. So in order for this to work, we actually have to have walk number outside the pproc, and i.e. making a global script variable, variable set equal to 0. It has to be initialized to 0, so he goes to the first one. Put this at the top, so he'll go to the first one, and then he'll go to the second one afterwards, and the third one afterwards. No, this is fine. This should actually be set up in here. The walk number equals number plus 1 should be set here, here, and here. Oops. And the variable declaration has to be above all of them, so it has to be like up here. Compile. And now we should see him walk to each one with a bit of a delay, though, still, because that one is kind of slow. There we go. And then let's see the third one come up. The reason this is so slow here is really simply because the map update pproc is not called nearly as often. And also we have a bug right there where he goes back number 2 instead. The faster place to put it would be in the critter pproc, so it'll happen a little more often. Happen a lot more often. In fact, everything should be pretty much 1, 1, 1. He'll go there, and he should come back here. In theory, except that, of course, that's not really the perfect way to do it. All right, hold on. You gotta walk through a little more logic in order to get this to work. This needs to be here, I think. Once it's on 3, it just needs to be 0 at 3. Once it gets to 3, we just set it to 0 here, and then it'll go back and forth, and that should be fine, actually. We don't need to do anything else with it. 1, 2, 3. 1, 2, 3. Okay, so now there's no weird pause at the end of the walk. Now he's walking around all the time. So the critter pproc, because it runs 10 times a second, allows you to do this. So this is another way of handling it. The other way I showed you is actually a little better, but this one works as well. And I've seen this done as well, because the walk number will keep track of which one it's supposed to be on, and it only increments the walk number when it's actually not animating anymore, and it only increments it once because it only runs this once. And this walk number here allows it to tell which one it is. FP walk 2, FP walk 3, FP walk 1. Because those numbers are literally ints. They are literally the numbers 0, 1, or 2. That's all they are. And that's how you can go through an animation set like that. The third way of handling this is to do the same thing. It's to have a walk number that you're assigning down here in the critter pproc. But instead of just having it call it every single time, you have a check if tilenum self object is equivalent to the tile numbers that we're looking for, hex 1, hex 2, hex 3. So hex 1, then begin. We do the same thing here. We do this here. And we get an end here as well, end. But the walk number will be walk 1. And then you could just go ahead and do the same thing over again. If it's hex 1, then walk 1. Else if is hex 2. And then we do the same thing, except walk 2. And you can see where this is going. It's exactly the same thing for walk 3. Hex 3, walk 3. This is the other way of handling it in the critter pproc if you wanted to do it this way. And we can get rid of all the walk numbers. This should work at this point. Let's give that a try. There is a bit of a delay because the critter pproc isn't perfectly every single time. So, but you can see he still is going around in a circle correctly. And that logic is pretty easy to follow as well. For most of the time when you read enough of these scripts, that logic will be pretty easy to follow. So if it's hex 1, go to hex 2, basically, FP walk 1. If it's hex 2, go to FP walk 2. If it's hex 3, go to FP walk 3. And that's all it's doing. It's just calling each of these based on the tile he's currently on. There is a bit of a delay, so this one might actually be a little bit better if you want more consistent walking, but this will also work. So I've seen all 3 of these solutions. This one's probably the best solution right here, where you have it end else begin, call the same timer again. One more thing about the timed event pproc, you don't have to call it explicitly on the critter you're calling it on. When you call the timed event pproc, add timer event here, you can call it on a different critter. But the thing about this is a little more complicated because you need a second script for this. So this is a timer. I'm going to go ahead and make a new one called, this one I'm going to call B timer. Just so we can differentiate them, and I'm going to go back to the map. And I'm going to go ahead and add that chick back in, and we'll put her right here. And save this, close the mapper, and then go ahead and let's just go ahead and copy all of this over here. And what we're going to replace some of the information. Oh no, actually what we're going to do is we're going to comment this back in. We're going to comment this back in. We're going to comment this back in. And then we're not going to have her called at all. We're going to get rid of all of this stuff right here, so that she isn't being called from the original script. So let's give this a, I have to go to list, register it, and then close, and then compile, and go back to the game, close the game, load the game back up. And now she's here. Now her script is there. She's got the timer events in her script, but she's not running at all right now. See, just want to show that off. She's not running. Only this dude is running. That's all that's going on. But if I go back to this dude, this is the dude script right here. And in the map enter pproc, instead of, we're going to take this out because this basically runs it twice. But we're going to take, instead of doing on map enter add timer event to self object, we can actually add timer event to the critter itself. Getting the critters, a pointer to the critter is a little more difficult though, and a little more complicated, and actually we need the mapper open for this, so there's a couple ways of doing it. One of the easy ways to do it is take a look at what the hex number is, 19494. Go back over here and say, how define critter pointer. In order to get the critter PID on a specific hex, specifically this hex right here, 19494 is the hex number. We have to go and say tile contains PID object, which will return the object pointer here. Give it the tile number, the elevation number, which is 0 in this case, and then the PID number, which you can find in critterpid.h if everything's set up correctly, which in this case is PID primitive villager female. You can either use the number itself directly, or I recommend using the define as long as it's there. If the define is not there, I seriously suggest you add the define in. But either way, that's the PID we're looking for. That's how it contains PID object, this. And instead of self object here, we call critter pointer right there. Because that critter pointer is this define right here. Notice there's no semicolon at the end because it's a define, so it's handled differently. So you don't generally want to put semicolons at the end if you can help it. And this text will replace where it says critter pointer right here. It'll replace that, and this will find that critter, and it will add the timer event FP walk 1, which is in this critter here. And I'll show you, I'll remove these and show you what happens if they're empty. And we'll go and compile this, because this is the only one I changed, to the game. Load that up. And now when he triggers, in theory, oh, okay, hold on. Oh, okay. All right, fair enough. We'll have them both start up at the same time. Compile. The goal is to exclusively have this guy set her script to run. And I completely forgot to do that. So edit, new script, B timer. Here's B timer. Done. Now we can see he has A timer, she has B timer. Let me save it. And let me go back to the game now. Okay. So now he runs and then she runs at the same time. Now he's going to have a weird little delay because he never actually made it to here. Oh, he won't. Oh, he crashed into her and he'll never actually make it to this one. So that this is the one downside of running the script the way I have it set up over here for this critter, is that if he gets interrupted in any way and he's not on the tile that he needs to be on when the script is supposed to call, then he won't actually do anything anymore. He'll actually just get stuck. That's the one downside of running it this way. We're checking if tile num self object equals the tile num that he's supposed to be on. A better way is to do not in front of us. If he's not at this tile, so this should be if he's not at hex 2, walk to hex 2. If he's not at hex 3, walk to hex 3. If he's not at hex 1 here, then walk to hex 1. So that will actually prevent him from crashing. So that's a better way of handling that issue. So he'll get stuck, but then he'll keep going. He's gonna be right behind her. Now the one thing is that you gotta work out your logic again, because he'll end up stuck in certain situations. Yeah, so that was not right. Okay. So for something like this, if you have only 2 points, that works. But if you have more than 2 points, you need another thing in here that says, if not this and something else to prevent it from actually running here. So that walk, we'll call it walk flag. That tells him which one it should be. Walk number would be fine. Walk number, this should be like this. Should be like this. Equivalent to 0. Walk to hex 1. This is the one downside of trying to write the code like this. This is awkward to deal with. And walk number equivalent to 1. And then here, and walk number equivalent to 2. So that's right, I forgot to increment the walk pointer. The walk number here. Walk number plus 1. Put that here, and put that here. Compile, run. And now that should actually align. There we go. So now he's hitting all the things correctly. There's a... Oh, I forgot to do one thing. I have to set it back to 0 in number 3. This one's supposed to be just 0, not walk number plus 1. File, run. There we go. Now everything will work. Okay. So those are like what, 3, 4, 5 different ways of handling this. The timed event pproc is one of the more complicated things you'll ever run into. It's like really complicated, especially if you want to do multiple point animations where they walk around or do something at the position that when they get to somewhere, you know, go somewhere, pick up something, put it down somewhere else. It's really cool. These are the things that make building a mod for Fallout 2 really reactive and interactive. A series of scripted events where it makes the town look alive, where they're walking around, they're doing things, and they're talking to each other, is really cool, and it's what makes most RPGs look like they've been lived in, like they have things going on. But they're really complicated. But totally worth doing, and totally getting in here and actually getting them to do stuff is one of the cool things about modding Fallout 2. I'm still not sure why you need line 33 to start without that line. Okay, I'll show you. 130, which is over here. So we get rid of this. We don't need that. So in this case, I think you mean 132 here. Because I've moved everything around. Sorry about that, but that's what you mean. Oh, you mean 131 specifically. Okay. So, oh, okay. One more thing. Let me get rid of all of this stuff here out of her timed event pproc. So I'm going to clear out her timed event pproc. So she's got an empty timed event pproc, and I want to show this real quick. We're going to compile her again. So if she has an empty timed event pproc, but he does not, well, then take a look at this. So even though he has that timed event pproc, when he calls her timed event pproc, it's literally the timed event pproc that is in her script. His script does not apply to her at all. Yeah, I have a different script for the female. That's the issue. So in order to call a timed event pproc on another critter's script, that timed event pproc has to be in that critter's script in order for it to be called. So that's the thing you got to watch out for. So you can call a timed event pproc in another critter's script from your script. That's what I was trying to show there. Right, this way you copy code, which is not good. Well, yeah, if they do the same thing. Yeah, if they do the same thing, then yeah. But if, for instance, you wanted the critter to walk up to her and then have her do something and then have him walk back where they do two different things, then that's the situation where you do that, where you have him walk up to her, they have a conversation, they're done, she walks away, she does something else with another critter. You have him walk up to her, once he reaches her, he triggers her timed event pproc. Once her timed event pproc is running, he walks away, she goes and does her thing to another critter, and she triggers another critter's timed event pproc. You could chain scripts this way, which is really cool. It's a really complicated language, though, so you have to watch out for this kind of stuff. And you're going to take a lot of time trying to develop the script so that it actually does the things you want to do. So that's the last thing I can think of for a timed event pproc where you can do something really cool with it. You don't have to trigger it on the critter itself. You don't have to trigger it on the critter that the script is running on. You can actually trigger it on other critters. Now, there are better ways of getting critter pointers, object pointers for the other critters. I'm not going to cover those in this today. They're really complicated. They're always complicated. So I'm not going to cover them today. I'm just trying to explain the timed event pproc right here, and I'll try and cover them in the future. So that's everything I can think of to talk about for timed event pprocs. Hopefully that explains things in a way that helps people understand what's going on. And I hope you guys have fun modding Fallout 2.